Alright, so we're dealing with a normal distribution and we're dealing with finding the area above or below a point. In this case, if you pause and read the problem, we're dealing with the area above a point because they're asking what proportion of exam scores are higher than Ludwig's score. So I first just want to visualize this problem. So in order to do that, I'm going to import, we're going to do from SciPy, which is a library, import stats. We're going to import NumPy as NP, which is going to, we're going to use to get our x values for our graph that I'm going to use to visualize, and I'm going to import matplotlib.pyplot as plt, and that's what I'm going to use to also visualize, I guess. Okay, so now that I have that, let me just run it. And then first things first, I'm going to do np.linspace. So this function is basically going to get all your x values. So for example, I'm going to do, according to the problem, mean of 40 points. So I'll do like not negative 30, I mean 30 to maybe 50, and then do like 1,000 values in between. And that's going to give me an array starting from 30 and ending at 50 and giving me 1,000 values in between. And then I'm going to set that equal to my x values, okay, and my y values is going to be stats.norm.pdf, so our probability density function, and we're going to calculate the probability density function for all of our x values with a mean of, the given mean of what did they say, 40? Of 40, so that's what loc stands for, and scale stands for standard deviation, so the standard deviation they gave us was 3. So that's going to be our y values. And a little tip, just think of the only one that starts with S is going to be standard deviation, so the other one must be mean, right? Scale starts with S, so standard deviation, and then location is mean, okay? And then I'm going to do plt.plot, so I'm going to plot the graph, and I'm going to do the x values, and I'm going to do y values. I'm just going to plot that real quick, and you're going to see that it starts at 30 and it ends at 50, and the mean is a 40, which is what it should look like, and then you can just see that it's there. So that's how you visualize the plot. And if you want to do plt.title, you want to say a normal distribution. Let me do something real quick. Let me copy these symbols. Oops. Normal distribution with mu of 40, mu stands for mean, and a standard deviation of 3. And that's sigma. Sigma stands for standard deviation. Now it's frozen. Great. Okay. Run that, and then you'll get a title at the top. Then you want to do plt.xlabel, and these are going to be your, we could say your values, and then plt.ylabel can be the density, I guess. It's a probability density function. Yeah, so that's basically what we're visualizing. And what we're trying to do is we're trying to find proportion of exam scores that are higher than Ludwig's, how do you say his name? Ludwig's score. Ludwig got a 47.5. So he got right about 47.5. Oh, he got right here. So we're saying, let me save image. Let me open my whiteboard. And then let me put that in there. Hold on. Okay, new whiteboard. Add image. If I could ever find it. I'm like not organized these days. Is it this one? pretty sure it's the only normal distribution that I have. Okay, let me increase it. Okay, how do I lock it? Okay, so basically what they're saying in the problem, really? Okay, is that Ludwig got a 47.5 on the exam. So he got a 47.5 on the exam right here. That's Ludwig's score. And so we're trying to find the proportion of exam scores that are higher than Ludwig's score. So that's basically all of this over here. And how do we do that? Well, we can do normal CDF in our calculator. We start with our lower bound, upper bound, and then our mu, that's not a mu, and then our sigma. So we could do normal CDF, our lower bound starts with 47.5, then we go up until infinity because it never ends, so we just say 1e99, or you can put any big number like 9999, whatever. Our mu is 40, and our scale, our standard deviation is 3. And so when we put that into our calculator, we're going to get a certain answer, but I'll show you how to do it in Python. So if you go, my bad, if we go down here, can't even see anything. We could do normal, hold on, stats.norm.cdf, and I believe we take our 47.5, we don't take our 1e99, we take our location, let's see if this works, I haven't tried this in a while, location of 40, and scale of 3, let's see if that gives us anything. Okay, yeah, so the only thing is that you have to know that a CDF function only calculates the probability of anything left to whatever number you put in. So because of that, you're going to have to do 1 minus whatever answer you get. So in this case, you're going to have to do 1 minus stats norm.cdf, whatever. Okay, it's literally taking 5 hours. It's like frozen. It always freezes. Okay, so 1 minus that answer, and you should get that probability. So that is the probability of, well, not the probability, the proportion of exam scores that are higher than Ludwig's scores. So this right here, this area is 0.0062. Okay, and let's check our answer. So if I go to Khan Academy, of course, they logged me out. Okay, let me try to find where I was. Next, don't look at that. That was optional. Okay, it was here. So you may round your answer to 4 decimal places, so it's 0. What do we get? 0.006. We could just round our answer here to 4 decimal places. We could just use our round function. Round that entire thing by 4 decimal places. Just get that answer. And copy that in here. And voila. That's how you do that. I'm just trying to make sure I went over everything. Hopefully I explained that well. Yeah, it's just something that you have to know, that normal CDF only calculates the probability of anything left to it. So anytime you have like a greater than or equal to sign, you want to do 1 minus whatever you get here, like whatever probability you get. If they're asking you for anything like higher or above or whatever, if they're asking you for anything lower or below, then you don't have to do 1 minus, because it this is what it calculates. It does, let me highlight for you. This right here is the probability of anything lower than 47.5. And then this whole thing right here, right, 1 minus all of that is this. Is the probability of anything higher. Okay, so it's just, you know, just figuring that out. And yeah, and then that's how you can do it with Python. And you can just put this in your calculator. I'm pretty sure you do second vars, and I think it's like 2. Let me just double check for you real quick. Oh, never mind. I think my calculator is dead. Hold on. I have another one. Oh. Let's see. You do second vars. Yeah, it's second vars 2. And if you have a TI-84, it's asking you for your lower, your upper, your mu, your sigma. I can't even spell. Like, that's so ugly. Okay, it's asking you for your lower, your upper, your mu, your sigma, and then it has a paste option. So your lower in this case is going to be 47.5, because that's your lower bound. Your upper bound, you're going all the way to E99. Your mu is 40, sigma is 3, and then you just click enter here. You hover over it and then you click enter when you press the bottom numbers, and you should get that answer. You just round and then you do 1 minus that, and then yeah, let me just do it myself. 47.5, 1 e, oh, not 1 sine, 1 E99. Where's the E? Like, I completely, okay, it's on J. 1 E99, mu is 40, sigma's 3, pace, yeah, and then you get 1 minus. Oh wait, they actually do it for you. Hold on. Oops. 0.89. Did I do it wrong then? Interesting. What if I did SF? Interesting. No, because it's supposed to be 47 point. Well, I'm still right. I still got the answer right. But turns out for normal CDF, in the calculator you get 0.99. But then I didn't get that for here, so what now? But that makes sense though. You would do 1 minus that. Why does normal CDF calculate it for you like that? When to do 1 minus. When to do 1 minus normal CDF. Now I'm doubting myself. See, this is why, like, it's so sad. How do you know when to? No, please. Whoa. Did they mention 1 minus? But it worked though. Wait, so normal SF versus normal CDF. continuous random variable. So norm, okay, one space PBF, okay, here it is. So CDF is a cumulative distribution function. SF is a survival function, also defined as 1 minus CDF, but SF is sometimes more accurate. Interesting. 1 minus CDF is basically what we would want if we were to use anything that's greater than cumulative distribution function. But like, when? Why does nobody talk about 1 minus CDF? Where was I? No, that's not it. Maybe I put the numbers in wrong. So for CDF, it's X, right? The value, locations. Oh yeah, I did it right. So what's the issue? And if I do code and I do, or maybe it's because I put, oh my god, it's because I had 1 minus SF there too. Oh, I'm so dumb. I was so scared that I was wrong. Turns out I just had 1 minus when I checked if it was dot SF. Yeah, so we're good. Yeah, thank God. I was so scared. But here's the thing though, in the calculator, they didn't do 1 minus that. It just gave it to you. So when do you do 1 minus in the calculator? 1 minus that probability. I thought that you use CDF, you would have to do 1 minus. Because aren't we using what's greater than? When to do 1 minus CDF, AP stats, normal distribution. No. Well, I guess. I don't know, maybe. That's what I'm saying. Look. For example, blah, 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 blah. The CDF for the point for each x value. The CDF fills weight at any specific point is equal to the curve to the left of that point. That's what I just said. Use the CDF to determine the probability that a randomly chosen cancer that has a fill weight that is less than 11.5 ounces. So we would do, okay. So we would do 11.5 ounces. So we would do normal CDF, stats.norm CDF, stats.norm.cdf, parenthesis, 11.5, parenthesis, what is it? What's the mean? 12, and then parentheses 0.25. And then that would be fine. But then for greater than, we would do norm.stats.cdf, parenthesis 12.5, and then comma 12, comma 0.25, and parenthesis, and do 1 minus all of that. Right? So calculating the derivative function p-value is 1 minus CDF. Yeah, that's the probability value. Suppose you perform multiplication regression with the following degree of freedom. Calculate the input F test from one input a single value for distribution. Select F. 0.3 is probability for one to get the calculated p-value, because if that was for what? Distribution dialog box, regression with the following degrees of freedom. Regression 3 divided by 25 versus 2.24. But then that would be 1 minus. Okay. Yeah, I was right. Okay, but that doesn't make sense though, because in the calculator I did that and I didn't have to subtract that from 1 because it already gave me the answer. So isn't that an issue? And the answer is 0.062. So is it just me? Or is it my calculator? don't know. I don't know. I honestly want to save this because this looks really good. I don't even have a folder for it. Okay. But I'm gonna do something. Why does nobody talk about this? Okay, I'm wasting too much time. No. Yeah, okay, I'm not gonna do this anymore. I solved the problem. I don't need to. I'm right, okay? It's just. Let's get over it. I'm not posting this, by the way. Bye. Oh, I'm wrong. Wait, wrong page. Okay, bye.